In this lesson, we're going to take a look at the sine and cosine ratios, continuing on with our study of trigonometry. All right, so we know that when we have two triangles that are both right triangles and they have an angle here, let's say 36.9 degrees, and I got another triangle that's a right triangle that's 36.9 degrees. We know that those are similar triangles. We talked about that. And so we know all their ratios are equal. So if I take this guy, 3/5, that's going to be equal to this ratio, 6/10. And you can clearly see that those are just doubled, all right? So that's the same ratio, okay? We can also see that the ratio of 4/5, that ratio there, is going to be equal to this ratio of 8/10. And those are going to be two really useful ratios for us. This one here is going to be called the sine of the particular angle, which in this case is 36.9, and this guy is going to be called the cosine. And so just like tangent was just a ratio of the opposite and the adjacent legs, here we have two ratios of legs and hypotenuses. Notice I put the hypotenuses on the bottom. Okay, so let's take a look at these. So let's think about this first of all. Could we find the missing lengths of these triangles with tangent? In our last lesson we did that. Well, here we've got a 13. How does that relate to that angle? Hopefully you're thinking opposite. This is the opposite leg. And this guy is the adjacent leg. And we know tangent of, call it angle A just for kicks. Tangent of A is opposite over adjacent. Okay. Well, in this case, we could say tangent of 28 is 13/x. And we won't right now, but we could solve that. Okay? Because the tangent tells us that ratio. We can go to our calculator and do that. Okay? How about this guy over here? Is it possible to find this angle? Well, going to the other side of the triangle, this is our opposite, and this is our adjacent. And so we know that the tangent here of this 39-degree angle has to be equal to x/22. And as we saw in the last lesson, we know what this is. We can go to our calculator and figure that out, and we can solve for x. Again, not going to do it right now, but we can continue that there. All right? How about this? This guy over here is the opposite. Do we know the adjacent? No, we don't. Do we want to know it? No, we're looking for the x. So in this case, we don't know the opposite or the adjacent, so tangent's not going to help us. Okay? So tangent doesn't work here. Okay? What about on this other guy? Doesn't work for the triangle 3. Does it work for this one? Well, the tangent is opposite over adjacent, as we just said up above. And so here we don't know the opposite or we don't know the adjacent, so that's not going to work. Okay? So again, tangent doesn't work here. All right, so we need something else, and that's where these new ratios are going to come in. So let's define some new ratios here. The first one is going to be called the sine, okay? And it is written out S-I-N-E, sine. And it's abbreviated sin, but don't say sin in class. Call it sine. This is a sine of A. That is the length of the leg opposite to angle A over the length of the hypotenuse. So if this is our angle A that we're talking about, if we want to make a sine ratio, we're going to go all the way to the opposite side, find that length, and put it over the hypotenuse. Okay? If we want to find the cosine of angle A, again, this is cosine, written C-O-S-I-N-E. We're going to take the leg that's adjacent to angle A, this one, and put it over the hypotenuse. So, first quick example, if we go, you know what? Let's back that up. Let's go like this. Okay. kind of that one that we just had at the beginning. If we want to find the sine of A, sine is the opposite over the hypotenuse. And the opposite to A, go from A, find the opposite leg, and that is 3. And the hypotenuse is this big guy here, 5. That's the hypotenuse. This is our opposite leg, and this is the adjacent leg, just like we used in tangent. So if we want the cosine, we say cos of A, cosine of A is adjacent over the hypotenuse, and we'll abbreviate it like that. And the adjacent in this triangle, start at angle A. Which leg is connected to it? It's 4. And the hypotenuse is 5. You have it. Very similar to tangent, but just using different parts of the triangle. Okay, here's another triangle. So we want to find the sine, cosine, and tangent of these, or actually not the tangent right now, but so remember that sine, let's look for the sine of S, angle S, and that's opposite over hypotenuse. Sine, so we start at angle S, because that's the angle in our sine. Opposite, go to the other side, that's 63. And the hypotenuse, that's 65. Okay, hypotenuse is not going to change. Hypotenuse is always the hypotenuse on the opposite side of the right angle. It's always the hypotenuse in this triangle. But cosine of S, well, that's the adjacent leg over the hypotenuse. And so the adjacent leg is to S, to angle S, because that's the angle we're using, is 16 over 65. Now, by the way, we've got to check to see if these can be simplified. Is there any common factor for 63 and 65? If we look close, the answer is no. There is no. But simplify these fractions if you can, all right? So there we have it. Now, the directions also say we want to find it as a fraction and as a decimal. Okay, so we can find this as a decimal. We can go to our calculator, and we can find, that's a funny approximate. The squiggly means approximate. Remember that, okay? So, all right, so let's go to our calculator, find those. Punching them into our calculator, just dividing top to bottom, we get these numbers, 0.692 and 9692 and 2462. All right, let's find the cosine, sine and cosine of R now. The sine of R, well, that's opposite over hypotenuse, okay? And so the sine of R is going to be the opposite to R, which is 16. Now we're starting at R, and we're going from the opposite of R, and the hypotenuse is still 65. Okay? The cosine of R is the adjacent over the hypotenuse. So starting at R, we're going to go adjacent, that's 63 over 65. And look at this. The sine of R, this angle, its sine is the same as the cosine of the other angle. And so these two guys right here are the same. And these two guys are the same. Okay? So this is 0.2462, and this is 0.9692. Okay? Now remember, in a right triangle, that these two angles always add up to 90. So this shows a point that when two angles add up to 90, the sine of one is equal to the cosine of the other. So if we flip here, here's another quick interesting theorem, that the sine of an angle is equal to the cosine of its complementary angle, 90 minus A, okay? The cosine of an angle is equal to the sine of its complement, so on and so forth, okay? So in a right triangle, the sine of one of the angles is equal to the cosine of the other. So if we want to find the sine of 56, now we can go to our calculator, by the way. The sine of 56 is, and you can, why don't you go try it out on your calculator. Punch out your calculator, see what you get. Pause the video, you should get something like 8290. Then go check the cosine of 90 minus 56. Well, 90 minus 56 is, that is, let's see if I can do some arithmetic, cosine of 34. And punch that into your calculator, and we get the same thing, 0.8290. All right, so kind of a useful fact. We'll tuck that in our hat. All right, now let's find some missing sides. So the next important thing, we want to use this. So to use this, let's find some missing side lengths. We're going to do the same thing as we did with tangent, all right? So here we want to find x and y in this triangle. So x, we got to ask ourselves this. How does x relate to the angle? Well, x is opposite. And what is the side that we know? It's the hypotenuse. And we think to ourselves, which ratio do we know? Opposite or hypotenuse? Well, we know that is the sine of our angle. And let's give it a letter for now. Let's call that A. Sine of A is opposite over hypotenuse. That's the definition. So the angle that we're looking at here is 26 degrees. The opposite we don't know, and the hypotenuse we do know. It's 14. Well, we go to our calculator and figure out what the sine of 26 is, and it happens to be 0.4384, rounding off. Okay? And this should look real familiar. It's just a different ratio, different button on your calculator. And so we see that it's just a decimal number equals x over 14. Well, we want to get rid of that 14, so let's multiply by 14 on both sides. And so don't actually take that out of your calculator. Leave that big number in your calculator and hit times 14, and we end up with 6.13. Actually, what does it say? Nearest tenth here. So that number there rounds to 6.1. All right? So there's our answer. Now, if we want to find y, well, again, the first question we ask ourselves, how does y relate to the angle that we know? It is adjacent. And so adjacent and hypotenuse, we know the hypotenuse, we know the adjacent. We also, by the way, know the opposite right now, but we don't want to reuse this number, okay, because it's rounded, it's not exact, so let's leave it alone. Let's use adjacent and hypotenuse. So which ratio uses adjacent and hypotenuse? That's cosine. The cosine of A is adjacent over hypotenuse. Start with that generic equation every time. Write that equation, substitute. We know that A is 26 degrees. The adjacent, we don't know. We're going to call it a y, and the hypotenuse is 14. Well, now we can go to our calculator, and we can find out that the cosine of 26 is 0.8988. And we got a 14 on the bottom. We want to get that 14 out of there. So it's dividing by 14. The opposite of dividing is multiplying. So let's multiply. Now be careful when the variable's on the bottom. We have to do a little cross multiplying like we did with tangent. So 12.58, which will round to 12.6, is our answer for y. And that's how we find the missing side. A lot like sine and like tangent. But we just got to say, which side are we looking for, and which side do we know, and decide should we use sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent.